Hi everyone, this is Leo Sailman with my final project for the University of Washington Professional and Continuing Education IoT certificate. This is for the third quarter IoT class taught by Richard Ortega. What I have here is a Raspberry Pi 3 connected to a SenseHat, which we're not really using, but also connected to a camera. And it's running a Docker image that came from Microsoft Custom Vision AI. And it's been set up so it can tell the difference between an Imperial AT-At and an Imperial TIE bomber. So the way this works is I can take my AT-At target, put it in my little target staging area, check my monitor to make sure I have the image well framed, and then I can go over to my computer here and fire things up. So bear with me and we'll just fire up the Docker image. It's actually running already, we just need to start seeing the logs of it. And we see the logs start to come through. And as you look at the logs, you'll see that it's starting to say AT-At at the very bottom. Stabilizes, there we go. Basically the second line of text from the bottom is consistently saying AT-At. There's also a number there, a very small number, a depressingly small number. That's how confident that it's an AT-At. So it's not very confident about it being an AT-At, but it does believe it's an AT-At. Coming over here with the AT-At, let's go ahead and pull the AT-At out of the target area. And let's put in the Imperial TIE bomber. Here's the Imperial TIE bomber. Take a look to make sure it's well framed. Come back to the console. And now, hopefully, yep, it says TIE bomber. And we can kind of go back and forth, switch it up. AT-At is looking at the camera this time. And let's see what we got. And second line right there, it says AT-At with a confidence of 2 to 4%. Pretty bad, but at least it's greater than a fraction. Now there's also a way to fool the system. Coming over here, we can take our AT-At and we can put it on its side. So now it's presenting something flat and rectangular. Coming over to the console, it now thinks that the AT-At is actually a TIE bomber. Running it the other way, target area, pull out the AT-At, put in the TIE bomber, but we're going to pose it like this. Not like that, like this. Vertical. Looking at the target, we have a tall, skinny shape that's kind of big. Looking at the console, the model now believes that the TIE bomber is an AT-At. Over here, our second line, it's actually toggling a little bit, but a fair amount of the time, we're getting AT-At. So we fooled the system thinking that the TIE bomber is actually an AT-At. Now we'll see where this model comes from. Coming over to Microsoft Custom Vision AI. Coming over here, there we go. So here's the model, and I've trained it on a bunch of images that I've basically scraped from a simple Google image search. We have a bunch of TIE bombers, we have a bunch of AT-Ats. At no time did I ever give it images of the actual models, only these photos off of Google. If we look at the performance of the model, which I'm hoping I can find in this constrained window space, let's see here. There we go, performance, how about that? Our performance is 100%, which for an AI is crazy talk. Never ever trust an AI that claims 100% precision or recall. So that's why we're decently well at telling the difference between an AT-At and a TIE bomber, even if our confidence is really, really low. Now I don't have time to load a new model and a new Docker image onto my Pi, but I can show you a different project, which was a project aimed at finding the difference between myself and my son. So I have a bunch of pictures of my son from various ages, from middle school to high school and possibly even some early college in here. And then I have some pictures of me, more conventional, more regular. And if I look at the performance of this model, this looks like a real and reasonably honest AI. So overall, the model has a precision of 94% and a recall of 79.6. And then for the two of us, I've got a precision of 97 and a recall of 87, and my son's precision and recall are lower. And that could be because I've got photos of him at very different ages, whereas the photos of me look more or less the same. If you're wanting precision and recall, best way to think about it is something like this. So, looking at this image, the precision can be thought of all the times it was true, comparing the true positives that it detected with all the positives it detected, whether it claimed it was true or claimed it was false. And then the recall is basically saying of everything that was true in the real world, comparing that with the subset of stuff that the AI also claimed was true, that the AI agreed with reality. So there you have it as a way to think about precision and recall. I'd also highly recommend the Wikipedia article. Okay, so that's my IoT project. There's the tools running. There's the equipment. There's the targets. Hope you had fun with this. I sure did. And maybe I'll see you on the next one.